This conference will now be recorded.
We are discussing Power Pivot. In the Power Pivot, so we are done with two classes, and I shared one extra video which explain about what cross filter direction, single and both, when to go with single, when to go with both. You can find in that video. And along with that, we discussed about many to many cardinality, right? So in the yesterday's live class, I discussed about what one to one, one to many to many, sorry, many to one, and many to many pending is the right. You can find that in the extra video. Please watch it and understand it. Fine. Today's class is class number 4. Another important class, class number 4. These are the topics I'm going to discuss as part of class 4. Uh, these topics are important. Let's start. Let me open Notepad. 8 p.m. batch. This is class 4 in the data modeling. Class 4. In the class 4, we are going to discuss all this. First, we will discuss few data warehousing concepts, like what is schema, what are the different types of schemas we have. Uh, Schema related things we'll discuss first, and then we'll discuss about a topic called what? Active, inactive relationships. Both are important in the point of interview. Concentrate. Fine. So to discuss the schemas, let's open Power BI Desktop. Open Power BI Desktop and bring some tables first. Bring some tables. Click on blank report. We know that we can bring the tables using what? Get data. Click on get data. You need to select the source. Let me bring it from SQL Server. We are bringing from where? SQL Server. Click on connect. This time I'll give the server name. I'll bring some tables from this time. I'll bring it from AdventureWorks Data Warehouse. Let me open the server. In this, there is a second database, AdventureWorks Data Warehouse. I'll bring couple of tables. First, I'll bring dim customers table, dim date table, dim product table, and fact internet sales table. Fact internet sales table. Just some 4 tables I selected. Just imagine all the 4 tables have proper data. All the 4 tables have what? Proper data. What you need to click on now? Load. We need to click on load. When I click on load, all 4 tables will get into the Power Pivot. Click on load. When I click on load, you can see the tables in the model view. Once you load the tables, you need to define relationships, right? What we need to give? Relationships. Let's go and give the relationship. Keep the product table this side and date table. I'm just changing the collapse all. Fine. Now you are seeing some tables and relationships. You are seeing what? Tables, relationships. These tables and relationships all together, we call it as one schema. We call it as what? Schema. So what is schema means? Tables and relationships together, we call it as one schema. Tables and relationships together, we call it as one schema. Tables and relationships together, we call as schema. Okay. So when it comes to schema, there are different types of schemas. What you have? Different types of schemas. What are the different types? Star, snowflake, galaxy. Okay, it's a schema. This might be one of the schema. It might be either a star or a snowflake or a galaxy or a galaxy. Tell me, it is which schema? It is star schema. How you are telling it's a star schema? Correct. It's a star schema. On what basis you guys are telling it's a star schema? Hmm?
One fact
Hmm.
table
All dimension
when it
table, one fact table.
called as task.
Right. Right. So if every dimension table is directly linking to the fact table, then it's a star schema, guys. If every dimension table is directly linking with what? Fact table. There are sometimes you'll have another dimension table. I'll show you that another dimension table will not link to directly to the fact table. That dimension table will link to another dimension table. Link to what? Another dimension table. That time it's not a star schema. So here, if every dimension table here, dim date table is a dimension table, dim product table is a dimension table, date is a dimension table, customers is a dimension table, and sales is a fact table. Every dimension table is directly linking with what? Fact table. Then the schema is what? Star schema. So first schema you have is star schema. What is star schema? When every dimension table is directly linking with the, if someone asks you to tell the definition, uh, in a schema, if every dimension table in a, I said that it's a schema, right? All this we call it as what? Schema. In a schema, if every dimension table, if every dimension table is linking with the fact table, dimension table directly directly linking with fact table, we call as star schema. We call as star schema. Okay, it's a star schema. Now, fine. Next schema you have is, okay, we'll discuss, guys. Now let me bring few more tables. Along with these four tables, there is a product subcategory table, product subcategory table, and product category table. Product category table. I'll bring those T tables also. To bring the two tables, you can use again what? Get data. Go to get data this time. Again, they are in SQL Server. Just enter the server name. Uh, just press same database. Press OK. I'll bring it from same database. Which database? AdventureWorks Data Warehouse. This time, dim product category, dim product subcategory. Just click on. Take an example. These two tables also have proper data. Click on what? Load. Now, this is also one schema. This one also one schema now. So tables and relationships all together is what? One schema. Can we call this schema a star schema? Means no, right? No. When it is a star schema, I said if in a schema, if every dimension table is directly linking with fact table, we call as star schema. Here, if you notice, this dimension table is not directly linking with the fact table. This dimension table also not directly linking with the fact table. So if you don't have these two tables, then it is star schema. With these five tables, it is what schema? Five tables. Snowflake. If
Snowflake.
minimum one dimension table is not directly linking with the fact table, then it is snowflake schema. What is the second type of schema you have? Snowflake schema. If minimum one dimension in a schema, if in a schema, if minimum one dimension table, if minimum one dimension table is not directly linking with directly linking with fact table, we call as which schema? Snowflake schema. Uh, Even with this, bring this table close. Even with this five tables, it's what schema? Snowflake. Even with the six tables, what schema? Snowflake. Right. So when tomorrow, when you join in any company, when you load the tables into the Power Pivot, when you load the tables into the Power Pivot, between the tables you will define the relationships. When you define the relationship, sometimes you'll get a star schema, sometimes you'll get a snowflake schema. See, you will just load the tables, you'll give the relationships. You might get any schema. You might get star schema or you might get snowflake schema. 99% in the real time, either you will create star or snowflake only. Star or snowflake. I'll discuss about galaxy schema also. There is one more schema called what? Galaxy schema, which we don't build most of the times. We'll build star and snowflake. We'll talk about galaxy schema also. Why we don't build also, we'll discuss. Now, most of the times you'll get the questions from star schema and snowflake schema only. First, they'll ask you, what is star schema? You need to tell this definition. What is star schema means? In a schema, every dimension table is directly linking with the fact table. We call as star schema. What is snowflake schema? In a schema, if minimum one dimension table is not directly linking with fact table, we call it as snowflake schema. Now, how to convert this snowflake schema to star schema? I have a simple question. First, is there any possibility to convert this snowflake schema to star schema? Currently, it is which schema? Snowflake. I'm planning to convert it to what? Star. Is there any possibility? Hmm. Tell me how to convert. I want to convert snowflake to star. Star. How to convert? Tell me your ideas. Convert snowflakes to star. There is a lot of questions you'll get in this area. How to convert the snowflakes to star? Hmm? What you need to do is you need to delete this relationship, give the relationship here. You delete this relationship, give the relationship here. Then it will convert to star. But if you want to give the relationship, you need to have a common column. But in category table and sales table, you don't have a common column. In subcategory table and sales table, you don't have a common column. That is the reason I'm not linking directly. That I'm linking through another dimension tables. So that possibility is not there. Sales table don't have common columns. That is the reason we are not linking. Hmm. What is the another solution? This solution will not work. What is the other solution? Hmm?
Can we
What is
merge?
the another solution? Huh?
Can we merge?
Yes. What we need to do is we need to join these three tables into one table. We need to join these three tables into what? Bring the columns from category table into one place, subcategory table into the same place, product table into the same place. You create one table with the help of these three tables and directly link the table to where? Sales table. Then it will become a star schema or not? Yes. So how can you convert? There is easy way to convert snowflake schema to star schema by merging the tables. By merging what? So you have a common column. If you want to join the tables, you need to have a common column. In these two tables, if you notice, what is the common column you have between these two tables? Product category key, product category. You can join this. And that result you can join with the product table. You have product subcategory key, product subcategory key. By merging all the three tables, by merging the tables, what you can do? Convert snowflake schema to star. Convert snowflake schema to star. Here I want to tell one point. One product category contains multiple subcategories. One product category contains what? Star means what? Multiple. One product subcategory contains what? Many products. Many products. One product contains many sales. Many sales. Look at this. One category contains multiple. Star means multiple subcategories. One subcategory contains multiple products. One product contains multiple sales. Multiple sales. Now you can join this three table into one table. Now tell me, when the schema is snowflake schema, how many tables is there? Snowflake schema, how many tables you have? Six tables. When you convert it to star, how many tables?
Four.
Four. Four tables, right? Four tables. A common question they'll ask you in the interview is, which schema will give better performance? A common question they'll ask you is, star schema will give or snowflake schema will give better performance? Which schema? Star schema. Why star schema? It have less tables. It have what? Less tables. So here, out of this, which schema will give better performance means, what is the answer is star. Why? What is the reason? You can when interviewer is asking, what is the reason? Less tables. Star schema will always have what? Less tables than snowflake schema. When you create, let's say you create a report on six tables, if it is taking 20 seconds, if you create the reports on four tables, it might take less than 20 seconds. It might even show the data in what? 10 seconds also. Here it need to join only how many tables? Four tables. Here it need to join how many tables? Six tables. Joining the six tables and showing the results will take more time. Will take more time. So that reason star schema will give better performance. Okay. One more question they will ask, generic question. In your latest project, which schema you build, they will ask. For this, any answer is correct. will not always build star schema, will not build always snowflake schema. In the interview, when they ask you in your project, in the latest project, in your latest project, which schema you build, you can answer anything, guys. You go and answer what? Star schema. You can tell we build a star schema. Any answer is correct. Even snowflake is correct. Just tell an answer. Then they'll ask you, uh, in that schema, how many dimension tables and fact tables are there? What one more generic question they'll ask you is what? Okay, you said that you build which schema? Star schema. They're asking what? In that latest project, how many dimension tables and fact tables are there? Again, for this question also, any answer is right. Roughly, you need to tell one number, one fact table, and around 10, around now I just bought only 4 dimension tables or 6 dimension table. Might be in the real time around 10, 12, 13 you might have around 10 dimension tables, you said dimension tables. So any answer is correct. It's not the same number again. Any answer is correct. Okay. Now here we will understand something called normalized and denormalized. We'll understand about two words, which is normalized and denormalized. Mm. So just to try to understand two words here, normalized and denormalized. Here I said that currently the schema is what? The schema snowflake. You need to convert the snowflake to what? Star. For that, what you said, you need to join the tables. Where you will join the tables? Which software? Power Query. You need to go to where? Power Query. Go to Power Query. Go to Home tab. Click on what? Transform data. In the transform data, you can join the tables. What is the first? You will join product category with product subcategory. First, you need to join which two tables? Product category with what? Product subcategory. Based on which column? Product category key. Product category key. Go and join the two tables first. I'm joining product category, product subcategory table. Product category contains how many categories? Bikes, components, clothing, accessories. 4 categories. Subcategories contains how many subcategories? 37 subcategories. 37. One category contains multiple subcategories, right? 4 categories contains how many subcategories totally? 37, right? Okay. Now I'll join these two tables. When the data is there in these two tables, it is normalized. It is normalized. Normalized means no duplicate values. If you see, categories are unique or not. In this column, subcategories are unique or not. They are unique. If the column have unique values, that kind of data we call it is what? Normalized. So when you can call one table as normalized is if the table have and if a column don't have duplicate values, if a column have unique values, if a column have unique values, have unique values, we call as normalized. We call as what? Normalized. So there is one more thing called denormalized. Denormalized. So let me tell you what is this denormalized. What is this denormalized is? I will go and join category table with subcategory table. To join this, where you need to go? Merge queries as new. I'm going with merge queries as new. I'm joining category table with subcategory table based on a common column called product category key, and scroll towards right, product category key. What column? Product category key, product category column. So in the product category, uh, category ID is unique. In the product subcategory, that will be many times. What is the cardinality you will have? So join, this is join, left outer join. You go with left outer join, just press what? Okay. Now you got a table which will have both category related information as well as what? Subcategory related information. What you guys need to do is once you join, you need to expand the columns. Go and expand the columns. Unselect use original column name as prefix. Press OK. You join the tables. When you join the tables, what you noticed is when you join category with subcategory, category column values got repeated. Yes or no? Bikes got how many times now? 3 times. Components got how many times? Multiple times. Clothing got multiple times. Accessories got multiple times. Whenever a column have repeated values, then it is denormalized. Then it is what? denormalized. When you join the tables, why the values will repeat? Let me show you. To make it simple, I'll bring EMP table and DEP table. Which tables I'm bringing now? EMP. To explain normalized and denormalized, I'm bringing EMP table and DEP table. When EMP data is in separate table, DEPT table is separate table, it is normalized. This DEPT table is normalized or denormalized? Normalized. How you are telling normalized? All column
Unique
values
values.
have unique values. Now when I go and join EMP with DEPT, see how to join EMP with DEPT. Go here, merge queries as new. I need to join EMP with what? Department. Common column is what? Department number. Go with the default join, left outer join. You'll get a table EMP DEPT. Now go and expand this table and select what columns you want. Dname and location, press OK. Now you guys tell me, you got the dname and location. It is normalized or denormalized? When you join the tables, few columns will get what? Repeated values. When the columns have repeated values, it is what? Denormalized.
Denormalized.
If a column have repeated values, if a column, obviously when you join you will get it, no doubt in it. When if a column have repeated values, repeated values, we call as denormalized. In the real time, they'll ask in the interview they'll ask one question. You said that star schema will give better performance. Which schema will give better performance? Star. And you also know how to convert snowflake to what? Star, right? Then why don't you build all the time star schema? I said that in the real time, sometimes you will build star schema, sometimes you will build snowflake schema. We are telling. You are telling that star schema will give what? Better performance. Star schema will give better performance. And you also know what? How to convert snowflake to start. Why don't you build all the time star schema? Means star schema not only have advantage. What is the advantage of star schema? Better performance. Star schema have disadvantage also. What is the disadvantage? Star schema not only have advantage, it have disadvantages also. What is that? Star schema advantages and disadvantages. Let me write. Advantage is what? Better report performance. Better report performance. Why? Because you will have less tables. When you want to convert snowflakes to star, what you are doing when you want to convert snowflake to star, you are joining these three tables, right? When you join the tables, what happens? Few columns will generate repeated values, right? That repeated values will occupy more space. Imagine when you have the data in the three tables, if it is occupying 1 GB space, if you combine this three table into one table, it might even occupy 2 GB space also. How much it will occupy? 2 GB space also. Why? When you join, it will occupy 2 GB space. Repeated values. Repeated values. Columns will have repeated. See, when you have separately category information in category table, if you go to category table, category name only 4 times. If you join it with subcategory, category values are how many times now? 37. Instead of 4 values, if to store 37 values, it will occupy more space or not? Yes. What is the disadvantage of star schema? Disadvantage is it will occupy more space. It will occupy more space. Disadvantages, it will occupy more space. Okay, you understand advantage, you understand disadvantage. So if there is sufficient space in the power pivot, always Power BI developer will prefer to build what schema? Star schema. You join the tables in the Power Query, build a star schema. If you don't have sufficient space in the Power Pivot is unlimited or you have a limited space? Limited space. 10 GB is the space. If that space is exceeding, you might even go with what? Snowflake schema also. Right. Not only in the same way, opposite. Snowflake schema, uh, right? Snowflake schema advantages and disadvantages. You write star schema, right? Now write snowflake schema advantages and disadvantages. What are the advantages and disadvantages of snowflake schema? Advantage is what? Occupy less space. Occupy less space. Occupy less space is advantage or not? Advantage. Disadvantage is what? Report performance is less. Report performance is less. Lot of questions you'll get. Very limited points I written about star schema and snowflake schema, but you will surely get starting from what is star schema, what is snowflake schema, how to convert star schema, snowflake schema to star schema, which schema will give better performance, what is the schema you build in the project, how many dimension tables and fact tables are there, tell me what is normalized or denormalized, hmm? Star schema advantages, disadvantages, every point is one entry question here. Just try to understand logically. Okay, we got some idea about all about, we discussed about star schema and snowflake schema. What is the one more schema you have? Galaxy schema. Let's talk about galaxy schema. What is this galaxy schema is? Hmm, I'll open one document to explain it. Go to Power Pivot, Power Pivot material. What is there? Data warehousing concepts. So you will see here. This schema is what schema here? Star. Customer is a dimension table, product is a dimension table, store is a dimension table, time is a dimension table, sales is a fact table. Every dimension table is directly linking with what? Fact table. It's what schema? Star schema. Scroll down. This is what schema? Snowflake. So brand is a dimension table, category is a dimension table, product is a dimension table. Now this dimension category dimension table is not directly linking with the fact table. Brand table is not directly linking with that. They are linking through another dimension table. Then it is what schema? Snowflake schema. Mm. Once after the snowflake schema, what is the third type of schema? Galaxy schema. I'll just explain for few minutes, just concentrate. There is ABC company which manufacture the cars and sell the cars. What is this company will do? They will manufacture the cars and they will sell the cars. Uh, when they manufacture the cars and sell the cars, they'll have manufacturing related data as well as sales related data. So first let's talk about manufacturing data. When you want to manufacture the car, you need some raw material. Who will supply the raw material? Vendor. There will be vendor dimension table. Who are the vendors supply the raw material? When you have the raw material, you will maintain the stock. Inventory dimension table will tell you how much stock you have, something like that. When you want to manufacture the cars, you need to have the staff. What you need to have? Staff. When you are manufacturing the cars, you will manufacture different models of cars. It will be available in where? Product table. When you are manufacturing the car, you will manufacture for so and so time period. The time period data will be there in where? Time table. To manufacture the car, you will spend some amount. That amount which you spend will be there in where? Inventory fact table. All these tables are related to which table? Manufacturing. So these tables, dimension tables are linking with the fact tables. Tell me this schema is what? Only this star
Star
schema.
schema.
It's one star schema. Every dimension table is directly linking with the fact table. It's a star schema. Only with this table, it's a star schema. Now, my company not only doing manufacturing, what they're doing? Sales. So when they're doing the sales, they will have some branches where they will do the sales. They'll have some locations where they will do the sales. They'll have some sales areas where they're storing the branches information in separate tables. Location information. One location might have multiple branches, or one sales area will have what? Multiple locations like this. Okay. Uh, uh, and to do the sales also, they will have what? Staff. Company is same, right? So as the company is same, manufacturing employees will store in same table, sales employees also will store in where? Same table. Table is same. Whatever the products they manufacture here, the same products will sell it or not? Yes. For so and so time period they will manufacture the products, so and so time period they will sell the products. There are some tables which are common for what? Both the subjects, manufacturing and sales. This staff table common, products table common, so and so time period we will manufacture, so and so time period we will sell. Timetable is also common here. Again, when you take these tables, it is what schema? Star. This one again a star. Every dimension table is linking with the fact table. How many stars are there here? Two stars. That is the reason we call it as what? Galaxy. Multiple stars we call it as what? Galaxy. It's a galaxy schema. I said that Power BI developer will not build galaxy schema. Instead of building galaxy schema, what is the alternative? Here two stars. What is that? Two stars. So what is the problem when you go with galaxy? More number of tables will be there. Model will become more complicated to understand, right? So I don't say we never create. There are chances we'll create it, but mostly Instead of going with galaxy, to make it simple, we'll go with what? Multiple stars. Multiple stars. Instead of galaxy schema, what I can go even do is I can go and build what? Multiple stars. Star schema. Um, Now let's write few points about the galaxy schema. Read these points. The schema is viewed as what? Collection of stars. Hence we called as what? Galaxy schema. What is the another name for galaxy schema is fact constellation schema. Some people will call galaxy schema as what? Fact constellation schema. In galaxy schema, few dimension tables, few dimension tables is shared with what? Multiple fact tables. If you see in the schema, this three dimension tables, time dimension table, product dimension table, staff dimension table, they are shared with inventory fact table as well as what? Sales fact tables. Whenever you see the schema which have multiple stars, whenever you see the schema with multiple fact tables which shared with common dimension tables, that kind of schema is what? Galaxy schema. You got some idea on what is galaxy schema also, right? Fine. Okay. We understand first part of today's class about all about schemas. What is schemas? All this you understand. Now second part of today's class. What is that? Act 1 inactive relationship. This is also one of the important topic. If you go here, let me delete all these tables, guys. I don't want these tables for time being. Delete them. Click on close and apply. Click on close and apply. Now when I go to manage relationship, if you see here status of the relationship, few status is what? Active. Few status is what? Inactive. What is this inactive? Why you are getting inactive? What is all this? We'll try to understand. uh, so what is this? To explain this active and inactive, let me delete all the relationships. uh, delete delete all the relationships. This time, to explain active and inactive, I don't want all the tables. I just want only date table and sales table. I'll concentrate only these two tables to explain what? Active, inactive. So for time being, you already yesterday I already explained what is product table, what it contains, right? I explained already what is customers table, what how it, right? And I also explained about what? Sales table. How these tables are related also I explained. You know about these three tables. Today let me tell you about this is one of the most important table for the Power BI developer. Date table is the most important table for what? If you build any project, each and every project will have what? Date table. Concentrate. This topic is important. What is this is? What is this is? Mm. Let me tell you what is date table. What is this date table is? First go to product table. I said that in the product table for every product you will have what? One product key. One product key. In the customers table for every customer you will have what? Customer key. Customer key. Customer key is what column? Primary key column. Dimension table, right? Dimension table will have primary key column and dimension columns. In the same way, in dim date table also, for every date, sort it in ascending order. For every date, let me close this. It is big table. I don't want. I'll open Power BI. I'll bring the tables from different database now. I'll just click on blank report. Let me bring the get data. I'll bring it from again SQL Server only, but this time from a different database. Copy the server name, enter the server. Database name is optional. Ignore it. Press OK. Now I'll just bring the tables to this time from product database. Same table I'll bring it. Sales table, time table. Instead of date, they're calling it as what? Time. Both are same again. Don't bother about it. Click on load. Click on load. Now, so I want to use these tables. If you go to these tables, this table between this time table and sales table, you have totally how many relationships is three. How many? Three. Out of three, one is bold line, two is dotted line. I'll tell you why you are getting dotted lines. What is this bold line? I'll tell you. Bold line is active. Dotted lines are what? Inactive. When I go to manage relationship, when I go to the status, how many active are there? Only one. How many inactive are there? Two. Dotted lines are what? Inactive. Let me delete this. I'll talk about it, why you are getting like that. Let me delete it. Now what I'm trying to tell here is, in the time data table, for every date you will have one time key. We have the date starting from 1st July 2001. 1st July 2001. What is the time key? 1. 2nd July, 2. 3rd July, 3. Like this, every date you will have what? One time key. So previously, for every customer you will have what? Customer key. Every product you will have what? Product key. That is unique, right? Hmm. So in the sales data table, they don't store customer name, they don't store product name, they will store their keys, right? In the same way, in the sales data table also, they don't store date. Instead of storing the date, they will store date related key. Date related key. So when you place an order, that order will have order date, right? Then order will have order date, but they are storing order date or order date key? Order date key. If you understand, one customer will place the order, whether they are storing in sales table customer name or customer key. Customer key. He will purchase the product, whether they are storing product name or product key. Same with so and so date, they will purchase the order, they will store date or date related key. Date related key. Now how can you understand this order was placed on what date? Just tell me, guys. There is, for this order, order date key is 1. Order date key is 1. What is the date for this one? How can you understand? How can you understand in first order what product they purchased means? How can you understand in the first order which product they purchased? How can you understand? You need to take product key to which table? Product table. You need to check it. How can you understand which customer placed this order means? You need to take customer key, you need to go to customer payable, you can check it. I want to understand on what date this order was placed. What date order was placed. So how, what you need to do is, you need to take this one, you need to take this to the timetable. Timetable to where you need to take? Time key. You need to take to where? Time key. So when time key is 1, what is the date? 1st July 2001. That means this order was placed on what? 1st July 2001. And the order was shipped on what? Time key is 8. Time key is 8. 8 means what date? Go to time data. 8 is what here? 8 July 2001. So understand, in the uh, in the sales table, generally you will not, you need to have order date. On what date the order was placed? You will have what? Ship date. On what date order was shipped? But they will not store dates. They will store that corresponding key. Sales table never have dimension columns. If it is, if they are storing date, date is what column? Dimension. If they are storing customer name is what column? Dimension. If they are storing product name, what column? Dimension column. They will not store dimension columns. Fact table will have what? Foreign keys plus fact columns, plus fact columns. So instead of storing that dimension columns, they will store that corresponding keys only. If you want to show the values, if you want to understand the values, you need to take that keys and you need to go to the table and you need to understand it, right? Now my client is asking to create a visual and asking to show date and sales. What they're asking to show? Date and sales based on order date. Based on what? They want to understand 1st July. 1st July, on 1st July 2000, what is the first date? 2001. How much is the sales amount? 2nd July 2001, what is the sales amount? 3rd July 2001, what is the sales amount? I need to see it here. So in order to see date and sales, date column will be available in which table? Time data. Sales column will be available in which table? Sales data. Go to time data table. Time column, the date column name is what here? If you see, date column name is full date alternative key. So they can write as date also, but they given the column name as what? Full date alternative key. When you want to see date column, when you want to see date column, go to the time data table, drag which column? Full date alternative key. Okay, you don't bother about it. It's split into 4 columns. Why it is splitting, you'll understand. Instead of splitting, if you want in one column, it is date hierarchy, you need to select what? Full date alternative key. You'll get in one column. If you don't like this date format also, you can change it. Select this column, go to format. There are different formats, right? Now it is taking date and time format. If you don't want date and time format, you can go and change to what? Short date. It will change. We are fine now. I want to show date wise what? Sales column is available in which table? Sales data. Now you don't have relationship between these two tables. When I go and drag the sales column, tell me guys, will it show the result, yes or no? Show, but what? Wrong data. It will show, but it will show what? Wrong data. Why? So one is dimension column, second one is fact column. It will show the data. It is telling every day you are getting 3.11 million sales, but it's completely wrong. Why it is wrong means? No relationship. In order to get the correct data here, we need to give a proper relationship here. I want to show date wise sales based on order date. Based on what? Order date. Here what is the common column is, understand. In the orders table, id column name is what? Time key. If you go to this table, in the time data table, id column name is what? Time key. The time key related data is stored in where? Order date key. Common column means it's not necessary the column name should be same. If you see here, now between these two tables, the common column is time key and order date key. Which column? Time key, order date key. This time key and this order date key is the common column. Understand? This time key and order date key is the common column. Common column means it is not necessary the name should be same. It's necessary the column data should be same. What you need to have? Data. Whatever the time key you have, that corresponding time keys is available in where? Order date key. I said that for every particular date, you'll have what? One time key. On the date when order is placed, the time key will be stored in where? Order date key. Then it is common column or not? Common column. Remember one point. People will think that common column means column name should be same. Common column means data under the column should be same. Common column means what? Common column means uh, when the data under the column is same, then it is a common column. Common column, mm, it's not necessary the name of the column should be same. It is not necessary the name of the column should be same. The name of the column should be same. What is required? Should be same. Even if it is different name, it's a common column, but the data under the column should be same. The data under the column should be same. Column should be same. uh, when it is same, then it is common column. Then it is what? When the data under the column is same, then it is a what? Common column or not? Yes. Now here the time key and order date key is the common column. If you want to give the relationship, go to where? Manage relationship. Click on what? New relationship. First table is time data table, second table is sales data table. The common column is in time data table time key, time data table time key. In the sales data table order date key. Which one? Order date key. And what is the cardinality is, in time data table for every date you will have a unique id. On that id 10 orders might be placed. One too many. What is the cardinality? One too many. Mostly you will have which direction? Single only. About the single and both I explained in the yesterday's class video. You go through it. It will be single only. I'll go with single only for now. Single is sufficient for now. Next one, there is a checkbox. Make this relationship active. When it is the first relationship you are building in the table, you will get which relationship means active. Now, so I'm building a first relationship. If you see, is there any relationship now? No. As it is the first relationship, you will get what relationship? Active. When I go and click on save, you got one relationship between sales table and time table. What relationship? Active. As it is the first relationship, you'll get active. Now you got the relationship between these two tables based on which column? Time key, order date key. Now when I go to here, it will show correct data. Previously it show wrong data, right? It will show correct data. Each day how much sales you are getting, it will calculate. Guys, how it will calculate is, it will take one date here. For that date it will identify what? Time key. The time key will send to where? Sales data order date key. Where? order date key. It will filter it. For that, it will calculate what? Sum of sales. It will calculate sum of sales. So now it is showing day wise sales based on order date or ship date? Based on order date. Based on order date. How you are telling based on order date? Based on the relationship. Based on relationship, it will calculate the values. Instead of showing day wise, I'll show year wise this time. Go and take one another visual. This time go to the time data table, drag the year, and go to the sales data table, drag the sales. From the sales data table, what I'm dragging here? Sales. You are showing what? Year wise sales. Year wise sales based on order date or ship date? Order date. So why you are telling order date? You have a relationship based on what? Order date. It will calculate. That means what is the meaning is in 2001 what are the orders was placed? Their sales amount. In 2002 what are the orders was placed? Their sales amount. 2003 orders sales amount. Each year what are the orders was placed? Their sales amount you are able to show. Now my client is telling that I want to see year wise sales based on ship date. What they want to see here? They want to see year wise sales, but this time they want to see based on what? Ship date. Ship date means in 2001 what are the orders was shipped, their sales amount. Is it the same or different? Different. Some orders which was placed on 2001, they will be shipped on what? What was placed on 2001, it will be shipped on 2002 January 1st or 2nd or 3rd or sometime. Okay, so the numbers will change. Numbers will change. What are the orders that was placed on 2001? There are chances they will ship on 2002. These numbers will change. Client want to understand year wise sales based on what? Ship date. Now when you want to show year wise sales, again you need to take year from the date table, you need to take sales from the sales table. But it will always show the data based on the relationship you have. You have relationship based on what? Order date. Even though when I take another visual, when I drag the year column from time data table, when I go and drag the sales year column from time data table, sales column from sales data table, it will still show year wise sales based on order date only. uh, Visuals will calculate based on the relationship you have. Based on what? As your relationship is there based on order date, it will show. Now how to show ship date? Now client want to see ship date, you want to give the relationship. There is another common column, time key and ship date key. What is the common column you have? Time key, ship date key. You need to give the relationship here. To give the relationship, again I go to where? Manage relationship. Again click on what? New relationship. Between time data table, sales data table, what is the common column is time key. Go and select the time key, and this time ship date key. Which one? Order date, ship date key. Ship date key. What is the cardinality? One to many. For each date, you will have one unique ID. On one day, 10 orders might be shipped or not. Multiple orders will be shipped. What is the cardinality? One to many. Take this single, default single only. There I explain when you need to go with both. Mostly you'll go with what? Single only. Very rarely you'll go with both. When we'll go with the both, you can understand in the third video. There is a checkbox here. Make this relationship active. That checkbox is not selected, guys. Only for which relationship it will be selected? First. From there, if you establish any relationship, this checkbox will not be selected. When I try to select this checkbox, save button was grayed out. That means you cannot have multiple active relationships. When I go and uncheck again, save button is what? Uh, Enable. Now, what you need to understand from that point is between two tables, we can have only one active relationship. That points I'll instead of typing it, I'll copy paste it from here. Read these points. Between two tables, how many relationships you can establish? Many. If you see now, when I make it inactive, click on what? Save. When I save, when I click on close, between these two tables, how many relationships you have? Two now. Two. You can even go and give third also. Third relationship will get active or inactive. Fourth one also inactive. Five, six, any relationships you can give. Between two tables, we can give many relationship. But between two tables, how many active relationships? Active will be one. So even though you have one active, one inactive. When I try to create the visual using two tables, it will show data based on active only. Read here. Visuals will show data based on what? Even though you have multiple relationship, it will consider only what? Active. Might be you will have a question now. When visuals are showing the data based on active, then what is the need of what? Inactive relationship. Huh? Now, even though you have active relationship based on what? Order date. You have inactive relationship based on what? Ship date. Now these visuals are showing year-wise sales based on order date or ship date? Order date. Hmm? Now my client is asking to show based on ship date also. They're not only asking to show year-wise sales based on order date, they also show asking to show year-wise sales based on what? Ship date. So, but unfortunately, you cannot show both order date wise sales, ship date wise sales. So let me show you one way. One way, now copy this result. This result is showing order date or ship date? Order date. I'm copying that result. I'm just copying it. Uh, if you want based on ship date, what I can do is, I can do one thing. If you want based on ship date, go to manage relationship. Where? Manage relationship. I'll go and make it active. If I make it active, which one I'm making active? Ship date. When I try to make it active, will it allow? When I go here, switch status to what? Active. When I try to make it, it is telling what? Error. Error. So ambiguous paths between. So meaning is, it is not possible to have two active in the same table. I already written here. We'll have only what? One. Now first what you guys need to do? Make it inactive. Switch to inactive. It allows or not? When I click on close, now both are what? When both are inactive, what visual will show? Visual show wrong data. Visual show what? Wrong data. Yes or no? Every year it is showing same value or not? Yes. So if you want based on order date, you make this active. If you want based on ship date, you make this active. You can make anyone active. If I go here, can I make it active now? Yes. If I make it active, it allows. Click on what? Close. Now it become active or not? Which one is active? Ship date. If you go and see, numbers are changing. You copied some numbers, right? Go and compare this number side by side. This is based on what? Order date. In 2001, what are the orders was placed? How much sales amount? 3,87,000. In 2001, what are the orders was shipped? How much? 3,70,000. We know that some orders which was based on 2001 will be shipped on what? 2000. When compared to this number is less. Is a meaningful result? Yes, it's a meaningful result. If you think logically, it's a meaningful result. So when the relationship is changing, result is changing or not? Based on that, you can understand that it is calculating the data based on active relationship or not. But my client want to see both order date year-wise sales, ship date year-wise sales side by side. Where? Side by side. So for that, directly it is not possible. You need to do some workaround. How many workarounds are there? Two workarounds. That workarounds we'll discuss in. They are related to what? DAX. So we are discussing Power Pivot. Power Pivot have two parts. What are the two parts? First part is data modeling. Second part is enhancing the data model with what? DAX. This how to show both order date wise sales, ship date wise sales is you have two workarounds to do show it, but we'll discuss in where? DAX. One more time for 20 minutes, I'll talk about active inactive relationships only. Which one? Active inactive relationships. Active inactive relationships. Active inactive relationships. Fine. What are the workarounds? How we can show? We'll discuss, guys. For now, carefully understand. If in order to do data modeling, first you need to come to where? Model view, and then you need to go to where? Manage relationship. This manage relationship window, we know about every option. Huh? What is new relationship? What is auto detect? What is edit? What is delete? All this also we know, right? Active, inactive, all this. And along with this, new relationship. When I go to manage relationship, click on what? New relationship. How to select the tables we know. How to select the tables we know. Once you select the tables, we need to select what? Common column. How to select the common columns also we know. And then we know how to select what? Once you select common columns, let's say like time key or order date key or any column you select time key. This time I'm going to select a different one, due date key. Don't bother about it. When you select this, you need to select what? Cardinality. Due date means ship date. Due date means when you place an order, they will tell you within how many days it will deliver, right? Might be they will deliver before that also. Before that, when they deliver, that is delivery date. This due date means within what date they will deliver. So okay, you don't bother much about it. How to select the common columns we know. How to select the cardinality we know. How to select the cross filter direction we know. Make this relationship active inactive we know. Now it is what? Active or inactive? Inactive. Why inactive? Already you have a active relationship based on time key, order date key. Remaining any relationship you give, inactive. We know active inactive also. There are two extra options are there. Apply security filter in what? Both directions. Assume referential integrity. These two options, believe me guys, 0.1% of projects also we don't use it, but try to have an idea. What I'll do is that two options we don't use in the companies. Don't use it. We never use it. But if you are curious to understand, even in interview also they don't ask the two options. You can even ignore it also. But if you are curious to learn the two options, what you can do? You'll get one extra video today. In that extra video, you'll find explanation about what? Apply security in both directions and assume reference. What is this two check boxes? When we will use the two check boxes, you'll find the explanation in this extra video. Even if you don't want to learn them, ignore it. They will not ask you in the interview, right? So this is all about data modeling. We clearly understand this new relationship window. What options are there? You need to understand cardinalities, cross filter directions, make this relationship active. These two options. Okay, good to know, but not mandatory. So we are done with by today's class. Which part? Data modeling part. In tomorrow's class, we'll start with what? Enhancing the data model with what? DAX language. Second part of Power Pivot is, I said that in Power Pivot, to create a OLAP database in Power Pivot, Power BI developer will perform what? Two activities. We discussed data modeling. In tomorrow's class, we'll start with what? Enhancing the data model with DAX. One of the important area. Around 10 hours of time, we'll talk about this DAX language. Right? Let's go with some questions now.